Hi everyone! Today we are going to be looking at similar figures. We kind of started this in our last chapter that we were working in, where we looked at figures that had the same shape. Similar figures, if you remember, are two figures that come from one another and they have the same shape. They don't necessarily have the same size. So they have the same shape, but not the same size. Congruent figures, which we've learned about, have the same size and the same shape. What makes them similar figures is that they have the same shape, like we can get one from the other, and their angle measures might be similar or congruent. Okay, so similar figures are figures that have the same shape. Not necessarily the same size, and one can come from another. So, and they use the word similarity transformation. And this is either a dilation or a rigid motion. So they have the same shape and come from dilations. That's going to change the shape, or rigid motions. And the word that we use to describe these two things here, the vocabulary word is similarity transformation. Meaning a transformation that creates a similar object. Okay, so we have similar figures. They will have the same shape, not the same size necessarily, but then they come from dilations and rigid motions. And remember that rigid motions are things like translations, rotations, reflections, those types of transformations. All right, so let's talk about what I actually mean with similar figures. So we're going to start with an example. And our example is going to give us two different shapes. So example A, and they're going to give us two different shapes. So let's go ahead and graph this. They're both triangles. So we're going to go ahead and graph two triangles. Apparently I've dropped all my pens on the floor today. That's what happens when I play with them during class. So we're going to have two figures, and we're going to start by just graphing and then seeing where we land. Okay, so let's go ahead and go with, move this over just so I have a little bit of space to write. Okay, so we're going to compare triangle ABC to triangle JKL. So our first thing that we're going to do is graph this one. 0, 3, 3, 3, and 3, 0. So let's go ahead and graph this very first triangle. 0, 3. So I'm going to start at 0 and go over 3. 1, 2, 3. Oh wait, did I do that right? Nope. 0, 1, 2, 3. That one's A. B is 3, 3. 3 and then 3. And then this one is 3, 0. Go over 3, go nowhere. And that one is C. I knew I wanted a dot there. Now we're going to connect these dots. Sorry, my pen has decided to conk out. All right, so there's our first one. The second triangle that we have is JKL. So looking at J, we're looking at K, and we're looking at L. We have 0, 6, and 6, 6, and then 6, 0. So we're going to graph these. So 0, go nowhere, and then go up 6. 1, 2, 3, 4, 5, 6. That's J. K is over that 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. JK. And L, 6, and then nowhere. And then again, connect our dots. And we want to know, my goodness, are these similar? It is time for my new pack of pens. Okay, are these two similar figures? Is triangle ABC similar to triangle JKL? Well, our job is to think about proportions. Are they the same shape? Yes. So we have the same shape. That is important. Check. Same shape. But now we need to think about, how do we get from one to the other? Because one is bigger than the other, so we want to see, is it congruent? Is it proportionate? So we're going to look at, how do we get from one to the other? Well, 0 times 2 gives us 0, and 3 times 2 gives us 6. So 3 times 2. So if I look, I'm here, and then I'm 1. I ended at 3 to 6. That's times 2. So if I multiply the other one times 2, that's how I get 0. Let's check this one. 3 times what gives us 6? Well, it looks like this is a scale factor of 2. And 3 times 2. So again, another scale factor of 2. So far, this one has K equals 2. And this one has K equals 2. So let's check our last one and see. 3, 0. 3 times 2 gives us 6. And we can just go ahead and say 0 times 2. We don't really know. That one equals 2. All right. Because we're on 0, we moved over twice. So if we multiply that by 2, we do get 0 still. Zeros are kind of tricky. So we get K equals 2. So they have the same shape, and it is a dilation. K equals 2, which means that it grew. So this is a similar figure. So we would say yes, similar figure. Okay, our next example is using the exact same triangles here, and it wants to know, is triangle DEF similar to both of these triangles? Is it similar to both of these? So let's look at triangle DEF. Let's see, I think I can make it purple. So I'm going to take triangle DEF and D, so here's try it number 2. Triangle D, it starts at 0, 4. And then E is 5, 4. And F is 5, 0. So 0, 1, 2, 3. Wait, X is 0. So go nowhere and then go up 4. 1, 2, 3, and 4. There's D. E is 5, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay. And then 5, 0. So we're going to go over to 5 and then go nowhere. So here's E and here's F. So we want to know, is this one similar based on what we know? Okay, well, it does look like it's the same shape. However, let's check to see if the dilation works out. So if I go from here to 0, 3, 3, 3, so if we compare it to triangle A, B, and C, we'll have 0, 3, 3, 3, and 3, 0. So 0, oh, that doesn't give us anything to multiply by. In fact, it's like a reduction there. So it goes from 4 to 3. And we can pull out our calculator and see what it is. So 4 divided by 3, and that gives us a change of 1.33. So 4 times 1.33. Okay, and then 5 to 4, so we know that's 1.33 on the 4. Let's try 5 divided by 3. 5 divided by 3, ooh, 1.66. See, it doesn't work out because already we have two different numbers. We have 1.66 and 1.33. So it is not similar to ABCD. Oh, just ABC. Okay. Now let's check and see, is it similar to JKL? Forgot the L. My goodness, Miss Englander. JKL. Let's check it out. So we have triangle DEF. So 0, 4, 5, 4, and 5, 0. And we want to know, is it congruent with, or not congruent, similar to JKF. So 0, 6, 6, 6, and 6, 0. Let's check to see, does it dilate using the same numbers? All right, so I get from 4 to 6. Let's check that one. 1.5. So 4 times 1.5 gives us 6. And we don't know about the 0. It could be 1.5. So let's check this one. This one will give us a good indicator. Well, we know that 4 times 1.5 is going to give us that 6. But what about the 5? 6 divided by 5 gives us 1.2. So that is not, and then down here we have 1.2. So this one is not similar. It's not similar to A, B, C. And the reason why it's not similar is because it does not use the same dilation. The dilation changes, which means that that triangle is not proportionate to either of those two triangles there. So the first one we had was similar. They had the same multiplier every time, and it just dilated. All right, and it was the same shape. Okay, it is your turn now for a try it. So I'm going to go ahead and give you a try it. Oops, no, we'll answer that in a minute. Okay, so try it. I was trying to have you answer your essential question already. Okay, the try it for today is to determine whether or not triangle MNP and XYZ are similar. So we want to know, is triangle MNP similar to XYZ? Triangle XYZ. Okay, so let's look at MNP. I'll give you those coordinates. M is at 3, 0. N is at 0, 9. And P is at 6, 8. And I want to know, is it similar to X, Y, and Z? X is at 1, 0. Y is at 0, 3. And Z is at 2, 3. All right, go ahead and hit pause right now so you don't hear me solving. And then when you are ready, come on back to the Google Meet and check your work. All right, so let's first check out and see what do we have here with our triangles. So let's go ahead and graph both of these and see what we are working with. All right, so my first triangle is 3, 0. So I'm going to go over to 3, 1, 2, 3, and nowhere. That's M. N is at 0, 9, so go nowhere for X, and then up 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. I'm off the charts again. And then 6, 8. So over 6, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, here is my first triangle. My first triangle, if you notice, is kind of slanted at the top. It goes down and it goes up like this. Okay, and then triangle X, Y, Z. So X is 1, 0. Ooh, so far it looks like it could just be times 2. Let's see. Y is at 0, 3. 0, 1, 2, 3. Or maybe it's times 3. It's right here. 1 times 3 would give you 3. Sorry. That one's times 3. X, Y. Okay, and then the last one is at 2, 3. Over 2. 1, 2, 3. Oh. Okay. So I already noticed right away that these are not similar. And I'm going to tell you why. Maybe you already see it. They are not the same shape. This one slants down. This one goes straight across. So these are not similar because they are not the same shape. All right, go ahead and answer your essential question. How do we find similar figures? And then rate your level of understanding out to the side, identifying similar figures. When you're finished, you can come on back to the Google Meet and ask for help, or you can go on to Big Ideas and do your practice work. As always, I appreciate all of your hard work and effort, and make it a great day.